So we're going to use related rates to find dx dt here, which is going to be the speed of the plane under these conditions. So it tells us in the problem that my plane is a height of 6 miles above the ground. It's going to fly directly across a radar station. It tells us that this s is decreasing, so this distance here, right, that's ds dt, is decreasing at a rate of 400 miles per hour when s is 10 miles. So s here is going to be 10 as well, 10 miles. And if that's 10 miles and the height is 6 miles, we have a right triangle here, and so we can say that x at this time is 8 miles. And so now let's write out what we're going to find. We're going to find dx dt, and dx dt is the speed of the plane when s equals 10, x equals 8, and ds dt equals 400. And since ds dt is decreasing, we're actually going to make that a minus 400 miles per hour. And so we need to see how can we relate s and x, because if we can relate those into an equation, we're going to be able to take the derivative of both sides with respect to with respect to t, and solve for dx dt. And so we have a right triangle here, and so I'm going to use the Pythagorean theorem. S squared equals 6 squared plus x squared. This is how I relate the decreasing distance between the plane and the radar station, and the speed of the radar station and the distance between the plane and the radar station on the horizontal component there. And so I'm going to take the time derivative of both sides, and so taking the derivative of s squared with respect to s, we get 2s ds dt, and again that's because s is a function of time. Derivative of 6 squared is 0, and the derivative of x squared with respect to time will give us 2x dx dt. And again, x is a function of time. As this plane travels, x is changing. And so here we can look and see that, well, 2 and 2 can cancel. We're looking, right, we want to find dx dt, and so solving dx dt is equal to s over x ds dt. And so now we can substitute the information that we have for our condition. So at this moment in time, the rate of change of the distance x, which is the speed of the plane, is given by 10 over 8 times negative 400, which is equal to negative 500 miles per hour. Now, if it asked for velocity, we would be done, but since it's asking for speed, speed is again the absolute value of velocity, and so our answer is simply 500 miles per hour.